Good afternoon, dear students. I am Dr. Sudarshan Behra, working as an assistant professor in the Department of Computer Science and Engineering in the School of Computer Science and Artificial Intelligence in SR University, Warangal, India. Today we'll start the course Compiler Design. Compiler design is a subject which plays very crucial role for computer science and engineering students as well as the allied branch students. Compiler, these are the outlines of the subject. I mean, for today's lecturer, these are the outlines. Here we will learn why compiler is required, what is the necessity of compiler, why not we can write the machine code directly, what are the different types of compilers and what are the different works. I mean, they are different roles. Why CSE students should study compiler design, why it is important for them. Then we will start introduction to compiler design, language processing system, and phases of compiler. Why compiler is necessary? Actually, the problem is computers understand machine languages. Machine language in the form of 0 and 1. But we human beings, or we are the programmer, we write the program using high-level programming languages like C, Java, Python, C++, where actually we mix some English text along with some mathematical symbols in order to formulate the program. So there is a gap between what machine understanding and what we are writing. So in order to minimize that gap, or in order to eliminate that gap, so a bridge is required. That bridge is nothing but the compiler. Okay. So what it does, a compiler, it converts the source code or the program written in high level language into machine code. That means it converts the program that we write using C, Java, C++, Python, whatever the programming language we use. So it converts that entire source code in the form into 0 and 1. It act as a bridge, or you may say it act as a translator, because it translates the source code written in high level language into machine code. So now from this particular slide, we can understand that why compiler is necessary. What is the advantage of, I mean, why can't we write the machine code directly? We can write the machine code in the form of 0 and 1. We can write up to some extent, but not every time. Why? Because it is very difficult to remember every code or every syntax in the form of 0 and 1. First thing. Then, so that means it may lead to some error sometimes. And it is a time consuming approach. It is not portable. I mean, it is machine dependent. You cannot write the program in one machine in the form of 0 and 1, and you cannot transfer to another machine, because it is completely machine dependent if you write the code using 0 and 1 only. It is hard to debug and hard to maintain too. So that is why a compiler or a translator or a bridge is required, which can convert the high-level programming language that we use, or the source code written in high level language to the machine code. What is the necessity of a compiler? It enables the use of high level languages. It improves programming productivity. It provides error detection. It also ensures efficient execution of the program, and it also provide portability support. That means if you write a program using C language or Java language, that source code, that particular program, if you run in your laptop, it may run. If you transport that program in the form of a text file or in the form of any other file, and you can execute in somebody else's laptop, then the program can also run. So that is called as portability. That is machine independent, because machine does not know the source, the high level language. So you can write and you can take it into different machines and you can run there. That is called as portability. So from this, what are the takeaways? What we understood, that without compilers, it is difficult to execute modern programming languages, and modern software development is impractical. And compilers are core to all the programming systems. So without compiler, it is difficult to run a program. So more or less, now let us focus what a compiler actually does. It reads the source code. The first step, it reads the what program you write. Once you click on the compile option, then the compiler work starts. So when its work start, what it does, it reads the source code. It checks the error. If any error is there, then it returns back to us. It translates the source code into machine code. Then simultaneously, it also optimizes the code. If we wrote very long code, and if some redundancy is there, some kind of lengthy code or complexity is there, it also simultaneously takes care of that. It also convert that code into a optimized code. So that optimized code, in the sense what? The code which can take less memory, as well as it can execute with less time. That code is called as optimized. But not every time that code should execute with less time and consume less memory. Sometimes the code may consume more memory, but it execute with less time, because time is very important factor. That is, the time and space both are called as cost in computer science and engineering. Okay, when we execute the program, we tell them what is the cost of the program. That means how much memory it occupies and how much time it takes to execute. Okay. Now see what are the different types of compilers available. There are many variants of a compiler. You may say one of them is cross compiler, which compiles the code for different machine. That means compiles code on PC and run on embedded system. I mean, it creates the executable code, the machine code, in the form of 0 and 1 for one machine, and that code can run in another machine. That is called as cross compiler. Then just-in-time compiler, which is used for Java language. Okay, it compiles the code during execution. It improves the runtime performance. So runtime performance, in the sense, it improves. It also perform optimization at the time of when the program runs. Then another compiler is there. Another variant is single pass compiler. It scans the source code only once Enter source code, it is scanned at one time. It is fast but limited optimization. It provides very less optimization. On the other hand, another variant of the compiler is called as multi-pass compiler, which processes the code in multiple times. So it does not run the code, scan the code or process the code in one time. Rather, it takes multiple time. It scan the code and process it in multiple attempts. It provides better error checking and optimization. Normally, it is used in modern compilers. This type of compiler is called as multi-pass compiler. Similarly, another kind of compiler is there called as source-to-source compiler. It converts one high-level language into another. For example, TypeScript can be converted into JavaScript. TypeScript is one language which can convert it into JavaScript. Or you may say C language can be converted into C++. Okay. So this type of compiler, it convert the high-level language written in one source code to another source code, not the machine code, not in the form of 0 and 1. It converts the high-level code or the source code written in one language into the relative language, another language. Then another kind of compiler is called as ahead of time, AOT compiler. It compiles the code before execution and it produces optimized code. So here, this particular compiler, it focus on how to optimize the code so that the code can run efficiently. This is the primary motto of AOT compiler. So these are the different variants of compiler and they perform different tasks and they support different types of user-friendly technique also. Now the question is why CSE or allied branch student should study compiler design? Because compiler is the backbone of the programming language. So whenever you are writing a program in a high level language, on the other hand, machine is understanding only 0 and 1. So you cannot convert the program into 0 and 1. So it will be difficult for the human being to convert the program into 0 and 1. So a translator or compiler is required. That is fine. But now focus why CSE students or the CSE allied branch student, AIML, data science, IoT, embedded system, why all those students should know about the computer? Because the fundamental to computer science, there are few concepts or the subjects. One is the data structure, one is automata theory, one is programming language. These are the major subjects in computer science and engineering. Or you may say the core subjects. So when you discuss about the core subject, data structure, for to execute anything or to create a data structure, you need to write the program. To work with automata theory or to understand the principles of automata theory. Automata theory is a part of the compiler. So you need to write the code. Then for any other programming language, whenever you are learning, without coding, you are not learning the programming language. So you need to write them. So whenever we are writing code, we should know what is the syntax and what kind of errors are there and what is the what type of how to execute the code and how whether whenever you wrote a code, how can you know whether your code is efficient or not? So So for all these things, it is essential to learn compiler design. Understanding how programming language work, how code is converted internally, what is the role of different phases of compiler, whether compiler perform the task within a single phase or there are different phases. Okay. So for all these things, it is very, very essential to understand how what is a compiler and how it works, how it convert the programming language written in high level language or the source code written in high level language to the machine code. Additionally, some career opportunities are also there. If you understand the concept of compiler properly, perfectly, you can be a compiler developer. You can be a language developer. Earlier, we have seen C language. Next, C++ came. Next, Java came. And now Python is running in the market. So, who developed these languages? Like you and me, like any other software, I mean, human being only. Software people, software engineers, or computer science engineers. They only develop this. So you can be a language designer. Tomorrow you can come with a new language, with a new compiler. That compiler can only able to compile your language. Then system programmer, you can be a system programmer because compiler is nothing but a system program. It is not an application program. It is a system program. So there are multiple career opportunities if you learn the compiler subject properly. It helps in competitive exams also. Like you can, most of the questions are coming from automata theory and compiler design. In GATE, in UGC NET, you can also, these are the competitive exams. If you learn the subject in depth, then you can easily attempt those questions. And few real world applications are like programming languages, C, Java, Python, any ID, I mean integrated development environment. Okay, for error detection, for auto completeness, all these things for game design, for operating system, you need compiler. Or to work with C, Java, Python, you need to understand what is the purpose of compiling C language, what is the purpose of compiling or interpreting Java, what is the purpose of compiling Python, what are the different syntax, all those things. So it will also help you for problem solving, like logical thinking, algorithm design, and debugging ability. If you knows the compiler properly, you can able to handle the debugging, or you can able to handle the error in a programming language. Simultaneously, you need to also be perfect in, you need to also be get expertise or proficiency in that programming language. First, you need to understand the syntax of every programming language. Then you need to understand before compilation how the compiler works. Okay. Now let us slowly go to the topic. Now the question is, what is a compiler? Now you can say, sir, a compiler is nothing but a translator which convert or translate high level language into into machine code or machine level language. Here you can say the input is source code. The source code is written in C and the machine code is in the form of binary. The output is binary. If you give the input as a program in C language, then the output will be the machine code in the form of binary. So when you write a program in C or Java, the computer cannot understand it directly. A compiler converts that program into machine language so that the system can execute it happily. Okay. So for that, a compiler is required. So you can see one example present in the slide. Int a equals to 10. That means you declare a variable and you also initialize that variable a equals to 10. Second statement, int b equals to 20. There another variable you declared as well as initialized, that is called as b. The value you have given 20. Now in the third statement, what is there? The third statement, int c, another variable, that c equals to a plus b. That means both the values of a and b as predefined. The values of a and b are added and placed in c. So the result will be 30. A equals to 10, b equals to 20. So and c carrying the result now. So the result will be 30. Is it as we wrote it? For our convenient, we wrote it. Is the machine understanding this? No. So here the machine needs to convert entire thing. Int a equal symbol 10 semicolon, everything it will convert to binary in the form of 0 and 1. And the machine understand. Then whenever you print the or you ask the value of c, the machine return you 30. Okay. Now let's move to another next slide. Language levels. There are many, many categories of language, like high level language. Normally you say C++, Java, Python. Then assembly language, it comes in the form of instruction. Okay, add R1, R2. There R1 is a operand and R2 is another operand. Okay, both of them added. The values are, R2 value get added with R1. That is the instruction. Then machine code or the machine language, it comes, you see, it comes in the form of 0 and 1, 1, 0, 0, 1, 0, 1, 0. It comes in the form of them. So we need to spend more time to understand that machine code to find out the value. Human prefer high level language because that language we can easily remember because we knows English and we knows the mathematical symbol. So we are combining both of them, the English text with the mathematical symbol, in order to create the program. Okay? Machine does not understand. Machine need to understand only when that program get converted into in the form of 0 and 1 into the machine code. So it is not that much of simple that compiler convert easily. Okay, it passes through several pages. Okay, so there is a system called as language processing system, which combines or which consists many components or which has many components. One is preprocessor, second component is compiler, third one is assembler, next one is linker, and next one is loader. This is a complete journey of the program before it get executed. Okay. So the language processing system, the first one is preprocessor. Okay, preprocessor, it reads the source code, then compiler, preprocessor, it performs something. Okay, it perform normally, it remove the macros, then it send the programs to the compiler. Then compiler translate the programs. Sometimes it translate to the assembler. Convert the program into assembly code. And some compilers are there which can convert the code directly to the machine. Okay. So compiler, then assembler, linker, then you get the executable files. This is the overall view of a language processing system. In this subject, we are not going to discuss what is preprocessor in depth, what is assembler in depth, what is the role of linker, loader in depth. We are not going. We need to discuss what is the role of the major role which is played by a compiler. Okay, so let's move on. See, you see the preprocessor, what it does, it handles macros. Like whenever in C language you are writing, no, has, include. So it removes them before sending the source code to the compiler, or has define. So it handles those macros. Then compiler checks the syntax, convert the code into machine code or assembly code. It also detect the error. If any error is there, it will not detect by the preprocessor. Rather, the error get detected by the compiler. Then compiler, once it detects the error and everything, if there will be nothing, if the code is fine, then it is sometimes it produces assembly code. Then it is sent that assembly code as input to the assembler, and assembler convert that assembly code to the machine. As in the previous slide, I told you, assembly code, there are the three different levels of language. One is high level language, then assembly language, then machine level, machine code. Okay, so here assembler, it converts that assembly code to the binary code or to the machine code. The linker, what it does, it combines multiple files, it links some libraries, okay, it establishes the linking between libraries, and the loader then loads the executable into memory. I mean, executable code, it places in the memory, and then it runs the code. So these are the overview of language processing system. Now the major subject need to be studied here is compiler or compiler design. This is the major thing we need to focus. So now let us come to know what is a compiler. As I said before, a compiler is nothing but a translator which translate high level, I mean source code written in high level language into the target code or into the machine code. Why I am saying target code, as I said before, sometimes the compiler does not translate directly to the machine code. Sometimes it translates to the assembly code. So either machine code or assembly code, that can be called as target code. So this job is not performed in a single step. Rather, it passes through several phases. So now let us know what are the different phases available in compiler. The major phases available or associated with a compiler are: first one is lexical analyzer, second one is syntax analysis or syntax analyzer, third one is semantic analyzer or semantic analysis, fourth one is intermediate code generation, fifth one is code optimization, sixth one is code generation. These are the major phases of compiler. Additionally, two other phases are there. One is error handler and other one is symbol table. Okay, error handler and symbol table. Let us know that. So you can see Yes, you can see here. You can see here. One second. Here. These are the phases of compiler. You can see the block diagram or the phase diagram of compiler present in the left side of the slide. The first phase known as lexical analysis, or you may say lexical analyzer, no problem. Second, what it does, it reads the source code, the first phase. Then it performs some task, and after that, it is send the processed input to the syntax analysis. This is the second phase of the compiler. The third phase of the compiler is semantic analysis. The fourth phase of the compiler is intermediate code generation. The fifth phase of compiler is code optimization. The next phase is the last phase, you may say, code generation. But let me tell you, this code optimization is again divided into two parts. One kind of code optimization is carried out as you see, as it is clearly visible in this PPT. Okay. One type of code optimization is just carried out before the code generation. That is called as machine independent code optimization. Then another kind of code optimization is carried out after the code generation. That is called as machine dependent code optimization. Okay, that we will discuss. When we will go to the topic, we will discuss that. And you see, additionally, two other pages are also there. One is symbol table, and other one is error handling. We'll be discussing them, each one of the phase, one by one, in depth. Now, just to read, discuss it in brief. Lexical analysis, what or the lexical analyzer, what it does, it converts the input. First of all, it reads the input or the source code. Okay, then it converts the input into tokens. Tokens in the sense sequence of words. I mean characters, not words, characters. It converts them into tokens. It also removes the white space and comments from the program. One example is given. You see, example int a equals to 10. So here, integer a equals to, the value is 10. The value 10 is assigned to a. Now, what will be the tokens here? If this is the source code, then what will be the tokens? The tokens are, first one is int, second kind of token is a, third kind of token is equal symbol, fourth kind of token is 10. These are the four tokens available in that code. So that is why we normally say, if somebody will ask you what is a program, what we say? A program is a collection of tokens. That is the perfect answer. So each one of the symbol or word present in the program is known as a token. So this lexical analyzer is normally perform tokenization. What is tokenization? We'll be discussing when we'll start the discussion on lexical analyzer. In depth, we have to discuss. Then the next phase is syntax analysis, or you may say syntax analyzer. It is sometimes called as parser also. It checks the grammar rules. It checks whether the syntax is correct or not. whether a sentence is grammatically correct, and it produces a grammar tree for the sentence. If the sentence is correct, it produces the grammar tree for the sentence as output. Then it is the grammar tree also called as parse tree or syntax tree. Then it pass that syntax tree as input to the semantic analyzer or the third phase or semantic analysis. What the semantic analysis does, it checks the meaning of the program. Whether a sentence is written, a sentence may be written correctly, but the eventual meaning of the sentence is correct or not. That is the role of semantic analysis or semantic analyzer. Then semantic analyzer, then after checking and everything, it pass the code to the intermediate code generation. Intermediate code generation, what it does, it convert the source code into a different form, into another form. I mean, it breaks the entire program into intermediate form. That intermediate form is called as three address code. Or it can also be some other form like DAG and others that we'll discuss. But now, in brief, you just try to know that it breaks the entire source code into another form. That is the role of semantic, role of this intermediate code generation. And once the code is converted into IR, intermediate code generation form, then it sends the code to the next phase, code optimization. Code optimization, what it does, it checks whether the code is, written correctly or not. If any redundancy is there, it removes that. If any other kind of, optimization is required, it perform that. Like if you are writing x equals to x plus 0. Otherwise, you take, suppose you are writing y equals to x into 1. What does it mean? You can directly write y equals to x. So that kind of optimization is performed by code optimization phase in order to improve the efficiency of the code. That's all. Next, finally, it passes the code to the optimized code to the code generation phase. And the code generation, it perform or it creates the target code for the optimized code. This is the job of compiler. And meanwhile, the symbol table and error handling, these two pages are associated with each and every page of the compiler. Symbol table, it is a kind of storage unit. It stores the details of the identifiers or the details of the tokens. And error handling, if any page, any kind of error is appear, then that error is thrown to the error handler. The error handler, it shows the error to us. That is the job of error handler. Okay. So symbol table is a data structure which stores the details of each and every identifiers or any other tokens identified in the program. And error handler, it checks the error. If any error is there, then it throw the error to the user for the corrective actions. Suppose I am the programmer, I wrote a program and there is an error. This error is identify the error handler or any of the pages, and that pages pass the error to the error handler. Finally, error handler will show us this is the error. We already encounter many times while writing the programs. If you have not done it, you can experience it when you write a program and compile, then error will appear. Then definitely the compiler will show you the error. That error shows through the error handling page. Okay, next class will be learning in depth. These are the different phases we just more or less we identified. In the next class, we'll be knowing in depth. We will take one for every phase. We will take one or two examples to understand how exactly they are working. Okay, so this is for the today's lecturer, and in the next lecture, we'll be learning what is the role of lexical analyzer, what is the role of syntax analyzer, what is the role of semantic analyzer, what is the role of intermediate code generation, what is the role of code optimization, what is the role of code generation, what is the role of symbol table, and how error handling phase works. Okay, in depth, with example, we'll be learning them one by one. Okay. This compiler design, it covers these phases are the entire syllabus of compiler design. So from next class onwards, we will be encounter them one by one. Okay. Thank you all. Have a good day. Thank you. Bye. Take care.